Kerry. Thank you very much.
Thank you.
Do I actually have to do this? Because according to our licences, we all did this on the 18th
Did we?
of May.
Oh dear, what shame, never mind.
Yes, exactly.
Remember it all.
Yeah, so on the 18th of May, we were supposed to be able to, to have demonstrated our compliance with the requirements of the EMF exposures according to the way that it's been described by Ofcom for frequencies of 10 megahertz and above, which is an extension from the 110 meg that we had before. The next thing coming along from that in November this year is frequencies below 10 meg. And we get into a little bit of that later. So I'm not going to go through some of the technical stuff that we did last time, because we did that last time. Okay. So the 18th of May 2022 was apparently the deadline for doing the frequencies of 10 meg and above. And we did all the ones of 110 meg and above. Well, it's up to 300 meg. No, it's 110 meg above. I think we did that back in January or something like that, or last November. Anyway. So as we said before, what we have to do is to work out whether any member of the public, which is basically anybody except me, or you if you're operating your radio, or somebody else, another amateur radio that you happen to be with at the time, that's like an interested party, will not be exposed to harmful radiation while you're using your station. It's virtually impossible for us as radio amateurs to actually work out what field strength is actually there at any one time, because there are so many factors to take into account. So we can take a sort of rule of thumb for most of those and work on what's called a compliance distance to say that where our source of radiation is, if that is further away than the distance that we calculate from a person that might be there, and that's any part of that person, then you should be okay. So our big aim here is to try and work out what the compliance distance is. And although it sounds fairly straightforward when you read what's in there, it's not. Okay, first thing to go through is one of the things it will ask you straight away when you're trying to put your numbers into the calculator is what's the gain of your antenna. In truth, an antenna has no gain. You can't get more power out of it than you put in. What it does have is direction. So what we measure against is something called an isotropic antenna, which is a mythical beast that transmits perfectly equally in all directions. It's actually impossible to create that. So it is literally a theoretical exercise. Nice bit pretty diagrammed I stole. They go on the top left hand, no, top right hand side.
We have all sitting there going,
Yeah, so it's, it's a hypnotic map. So basically, where you've got your point source, in order to do an isotropic radiator, it radiates in all directions. So that's a circle, but it should be a sphere. So it will radiate exactly away, and the amplitude of that will decrease according to the inverse square of the distance.
I can see a face in it.
Hmm?
I can see a face in it.
You'd be surprised when you get in there.
you take the tablets.
Okay.
Oh, that nice stuff.
Are we going to change? Right. One that will come across as well when we're looking at assessments of antennas and manufacturers' claims and various other things that we got. Well, there's this measurement called DBD, which is actually far more relevant to us, which is the gain compared with a dipole. And again, we look at the perfect dipole, which you can never create. So that would be a dipole that's got no reflections and no interaction with anything else. You'd have to locate it in free space a long way from a planet to be able to get it perfect. But it's good enough for what we're trying to do. And the reason that it has a gain is not because it's generating more power than you're putting in, but because it's not radiating in all directions. So there's more power being produced in some directions than others. So you take the point at which the maximum radiation is in that direction, and then the gain is the difference in power that you would have there compared with the isotropic radiator. And for a halfway dipole, we look on there, you can actually calculate it out. It forms a torus around the vertical plane of the antenna, shown on the bottom right there, and it's 2.5 dBi or 0 dBd. So you can easily interchange between the two by just adding or subtracting 2.15. Okay. Now the big problem for us is to actually work out what the gain of an antenna is at the frequency at which we're trying to use it at. And no matter what you go on the manufacturer's things, you'll either get something that's plainly untrue, or they just don't give you those figures at all. Now, if you're if you found it adequate training, you can use some modelling tools to be able to work out how a particular antenna behaves. But that is not easy and not for the faint-hearted, believe me. And trying to take into account things which are nearby means that that's probably not going to be that accurate anyway. But it will give you a good idea. So my sort of rule is to use a rule of thumb. The more directionality you have on an antenna, the higher the gain in that direction. So a Yagi antenna, that we call it, radiates more in one direction than it does in another. So in that forward direction, you'll have a lot higher gain. You get about 10 dB gain on a good Yagi antenna in that direction compared with a dipole. And if you've got enough space to put a parabolic reflector in, then you can get gain, but you can if you work at microwave or very high frequencies, which is typically used in radio astronomy, for example. You can get gains of 30 to 40 dB, and that is a lot compared with how big an antenna would you need to do if it was a halfway dipole to be able to get that sort of gain. You'd have to have lots and lots and lots of all stuck together. Okay, and the main reason is the forward direction lobe is much more sharp and much more narrow.
So that
And there's
one on
less.
the end is a dish.
Yeah, so they've got a dish here, and there's no radiation in the reverse direction at all. So all that radiation is being pushed in one direction forward. So there's no little side lobes apart from very tiny ones. And that's because the dish diameter can't be big enough to be able to cope with that. And there's nothing in the reverse direction at all. So all that power is being pushed in a very narrow beam out the front end. Okay. The reason I brought those up was the calculator that you'll find on the RSGB site just assumes that you're using an isotropic antenna. So it says the distance is from any point of that antenna which radiates. So it takes no account of that. But you are at liberty to do it yourself if you know how to do it. And you can justify it. Okay. So in order to calculate and demonstrate compliance with these new requirements, we need to determine basically three things. How efficient is our antenna? That is, how much of the power that we're putting into it ends up in radiation in the first place. Because not all antennas are perfect.
Can we measure that?
That is a figure that you can often get. If you don't know what it is, assume it's perfect. A magnetic loop antenna, if you're trying to use it and it's not on there, will actually only have an efficiency of about 60 or 70%. So you're losing 30% of the power before you've even started to think about radiating it. But that's not a lot, it's only 1.1 dB. So you're not going to lose a lot on by doing that. We also need to know the gain of the antenna at the frequency that we want to use in the direction where somebody might be standing. Or we just assume in every direction. And of course the distance away that person is likely to be. Okay. Sorry, guys. Okay. Once you have got all those figures, you can get them from a lot of different places if you try hard. You might be able to get it from the manufacturer, particularly if you're buying a beam. They will say that then because it's a nice little selling point on there. You can ask other amateurs. You can model it if you know how to do it. Or there's your good friend Google, as long as you trust what you're seeing. Okay.
Wikipedia.
Yeah, the Excel calculator that's there at the moment only works for frequencies of 10 meg and above, so you can't look at frequencies below that. But then again, at the moment we don't have to demonstrate compliance with frequencies below 10 meg. The online version, there is one that you can just do on the web without actually downloading it as an Excel spreadsheet. Don't. It doesn't work. Basically, if you use anything above 10 watts or anything below 110 meg, it just says no, can't calculate that. Use Excel spreadsheet. So, an example. Let's say, because I have, I've got a Moonraker GPA80 vertical antenna mounted on a gate post at my property. Okay. Doesn't give any gain from the manufacturer. You don't get anything like that from them, but you can get a radiation pattern, which basically says it's very, very similar to a halfway dipole, but just slightly tilted because of the ground effects. So I would say that it's safe to assume that it's very similar to a dipole, so it's not going to exceed 3 dBi gain in any one direction. I think you're okay to do that sort of thing. So, if with worst case that we're looking at, let's look at sideband. So if I was to use 400 watts and I talk for a sixth of the time, which is unusual, unless you really have a hell of a ratchet, and my antenna gain is 3 dBi, then you can work out that the radiated power is actually nearly 800 watts, give or take, because you've got 3 dB gain, so it's twice. Okay. Oh, did it, that's right. Sorry about the small print. If you then feed that straight into the next sheet on the calculator, which is actually the previous sheet, backwards on the RSGB calculator, you put in 798 watts or 800 watts, and I transmit for 1 minute in any 6-minute period, then it calculates out what your average radiated power is, which is obviously going to be a sixth of 800 watts, at 14 meg, so 20 metres. And it gives me a separation distance of 3.68 metres. Okay? And that's the number which is important for us. Okay? So if we obey the rules or obey the way that it's actually described to us, I have to make sure that no part of my antenna can come within, or a person can't get within 3.68 metres of that antenna. So I could mount it on a 5 metre yeah, 3.68 metres. You have to assume that a person's roughly 2 metres tall, so my antenna would need to be roughly 6 metres above ground, or above where that person is likely to be standing. Yeah, you wait. Yes, ma'am.
Kerry, I've got a Hustler antenna. It's a 6-band one,
Yeah.
and it's ground mounted. Now, there's coils that are near the ground, so how do you work that out?
Yep, exactly
You're not
that.
compliant.
And like my loop antenna,
Basically.
it's
Yeah.
only
Unless you put
2.5 metres off the ground.
Yeah. So you would have to do the calculations.
Also, how does that work if, say, for instance, you build an inverted L?
Yes.
Because if you've got a fiberglass mast and you put an inverted L up,
Yeah.
then your feed point is at the bottom of the fiberglass mast, isn't
Yes.
it? So it's up at the top, so
So somebody, you can't let anybody within 4 metres of that.
you'd have to do a radius of it.
Yeah.
No.
8 metres, yeah.
That's exactly right.
That's
You ask the neighbours to move.
They've made it
that's
virtually
somebody
impossible.
else. It's not you as the user. It's somebody else.
It's somebody else.
Yeah,
You're all
accept
right,
the
you can
risk.
fry
the risk.
yourself.
Okay.
You can fry your own brain,
Yeah.
but
Yeah,
you don't
you're-
fry anybody else's.
Yeah, you're allowed to fry your own brain, but you can't fry your wife's brain unless she's an amateur radio as well. So the idea is get your neighbours a licence and you're fine. In short, if you've got an antenna which you don't know the gain of, you've got to do a little bit of legwork and research to find out what it is. If you've got
What
a
about
house of
a
£6,
random long wire? A random long wire. How the blazes to work that?
I know.
Can you just assume it's got 1 dB?
It's going to get worse before it gets better, let me tell you that.
Right.
If you've got a multi-band antenna, you've actually got to do those calculations at each of the frequencies that you're likely to use. Because the
More
gain of the antenna will be different at each of those frequencies. One way of doing it is to say what's the best gain at that antenna at any frequency and use that
Yeah, it's the worst case
as
scenario.
the worst case scenario.
Yeah.
Because if you're compliant at the worst case scenario, then everything else is going to be compliant.
Kerry, quick one. Does the compliance distance or clearance distance increase as you go up the band or down? Or does it go down?
Yes and yes. Okay. I'll get onto that in a minute, if you don't mind, because later on in November this is going to get really messy for a reason which I'll get to in a second. So from that thing with my little boom raker that I've got on my gate post is actually mounted on the gate post, so it's only 2 metres above the ground. It's mounted not there. Which means if somebody was standing next to my gate, one, they'd be trespassing and they would get fried.
Cooked.
Or cooked.
Gets rid of the cat, doesn't it?
Yeah, and the other problem is that my neighbour, her house, is 2 metres to the left of me. So if she happened to be sitting in her room, right in that corner, then
No, but that's not 100% though, is it? Because nobody's calculated the absorption
that's
factor of
exactly
the brick.
right. Which is why I said
Yeah,
earlier
you
on,
might have.
if you are
wouldn't have to
prepared
worry
to
about
model
it.
it, you can. But trying to calculate that is not so easy. So all of these calculations that we'll see on the RSGB site assume the worst case, which is the permeability of the brickwork on there is, you know, it's 100%, you can get straight through without stopping. And it doesn't assume any other effects that are going on in there, including direction. If you want to model it, good luck.
Do the people who make Wi-Fi routers have to do this?
Yes,
They do.
yes.
How do they get away with it? Because Wi-Fi routers tend to sit on your desk.
Yes, but
You're like,
the wavelength is only it's tiny.
Wavelength is a couple of seconds.
Yeah.
So but that would make it.
The bandwidth doesn't necessarily affect it. It's the frequency at which it operates. It's all to do with the wavelength.
Right.
So questions that we all said there. What happens if you can't meet that? You've got some options.
Didn't hear that.
If you're not compliant when you do those
Oh, right,
calculations,
yeah.
like I said,
Yeah.
my neighbour is, if you sit in a room, is too close, and if somebody tried to burgle my house, I could fry them. So your options are move the antenna to somewhere where it is compliant. Not so easy for a lot of people. Don't transmit while there's somebody likely to be in that place. So
Open the door every
I
time.
could actually ask Susie next door, are you going to be in your front room today? And if she says, no, I definitely will not, then I could possibly use that as a mitigating answer and say, I would not transmit while there's somebody within that distance. Reduce the power, change your antenna type, okay, and all those sort of things, or you could use some advanced modelling. Or as you say, find some way of mitigating the risk that you can reasonably justify in terms of going forward. So if somebody came and challenged you, you would have a good argument to say, yes, I know that's within that distance according to the calculator, but again, purely up to you. Okay. This is a bit I said it's going to get messy. Okay. In November this year, it goes for frequencies below 10 meg. Okay. That 3.68 metres that we saw earlier, if you reduce the power down to a average power of 12 watts. I did that because if it's below 10 watts, you don't have to do anything. But if it's just higher than that, then there are two factors that come into play. One is the radiated field strength, and the other one is this reactive near field distance. And reactive near field, for a short antenna, i.e. something that's not of the same order of wavelength as the radio signal that you're using, is calculated as a wavelength over 2 pi. So when we get to doing top band, 160 metres over 2 pi, means your antenna has got to be 25.5 metres away from anybody.
No, it's not possible. It's impossible.
Yeah. So there's no clues yet as to what's going to be done about that. But that's where we're going. So the calculations are fairly straightforward. It's not difficult to actually use the calculator. It's just getting those 3 bits of information: distance, frequency, and gain. And as soon as you can work out what they are, it's just a matter of feeding them into the calculator and getting on with it. The problems will all come when that distance comes out as less than you've actually. It comes out as you're
correct
within
me if
that
I'm
distance.
wrong, but like for instance, like top band, for instance, so
Yeah.
that's 160 metres. That sort of frequency has far less impact on any organic material than a I don't know, sort of 70 centimetres.
Yes, possibly.
Depends how much power.
Oh yeah,
Absolutely
but
right.
obviously if you put in 400 watts,
You put a kilowatt out.
Yeah, you're going to know about it.
yeah, well I know that, but realistically, but I mean, it's sort of like powers we use,
Yeah, I know, yeah.
I can't see it.
Kerry, did you do the calculations based on the ERP of 100 watts, which is basically what most of our rigs put out?
Yeah, I can do that. In fact, I think that was all got now. This is my sort of warning shot.
Yeah.
Is at the moment, the way that it's being proposed is that it's going to be the death of top band. Because you would not, even if you're using a tiny amount of power, you're just not going to be able to use it. How many people can put their thing 75
Sorry,
feet up in the air?
Do you seriously think that the Ofcom is trying to push us into a corner where we just say,
I don't know.
The
I
thing
don't
is, no, it's not Ofcom.
It's not only us,
Ofcom,
it's not only us, Mark.
this is an
Sorry?
It's not only
international
us.
regulation.
No, it's everybody that
It
transmits
is.
the signal.
Yeah.
It's not Ofcom are doing it for the British, but it's the IT, it's coming down from, beyond our shores.
That's what the conversation's like in Italy, you know.
They don't listen to anyone, though, do they?
A lot of books you have before, so you can run short.
Yeah. There we go.
The way I see it, it cannot be just go down every.
Well, I mean, in one respect, I think I'm okay, I'm going to 10 metre max.
Some member of
The
the.
combat signal, only takes 20 metres.
There we go.
And then the VTV
That's
sits like that.
will come out. Somebody will say, oh, right, these guys.
Well, it's half.
transmitting higher power.
So if it's 25 metres at 160, because it's only based on wavelength. If it's 25.5 metres at top band, it's going to be 13 nearly at 80 metres, and even 13 metres is challenging. Yeah. Given UK planning rules, I think 99% of amateurs wouldn't be able to do it. So something will have to change. Okay.
And that's 13 metres long on a diagonal, not 13 metres
Yeah.
high. It gives you 15 metres on
What's
a
that in feet?
Well, unless you're standing directly underneath it. Unless you're standing directly underneath it, in which case it's vertical distance.
gents, sorry, this is, gents, this is being recorded for people who will be watching this offline later on. Can we please focus on Kerry and let him answer the questions one at a time?
Yeah.
Rather than a chat around the room, because that will not transfer. Thank you.
Okay, somebody said about 100 watts. So if I put 100 watts in, it says I'm generating 200 watts of power. And if I put the same numbers in there, so 200. Thank you. Okay. And I'm transmitting the same distance there. And I'm at 14 meg. Okay.
What's it 3.5 metres.
3.5 metres, 3.4 metres. Now it's 3.46 before, it's now 3.41. The reason is because you end up in this reactive near field distance, which is where we are. If you think about it, it's 12.5 metres or 13 metres at 80, it's going to be 7 metres at 40, it's going to be 3.5 metres.
You need to have set at
When
5
you get down
metres
to
above
20.
ground.
Hmm?
You need to have minimum of 5 metres above ground.
Yeah.
5.5 metres.
Kerry, that's saying that there's only 1 minute transmission time, is that right? That's what it says there.
If you're using sideband, most people that are using sideband aren't going to be transmitting more than about a minute continuously in any 6 minute period. In reality, it's probably even less than that. There are situations where that's not the case. If you're transmitting 400 watts FT8, then things are going to go seriously pear-shaped very, very quickly, because your average radiated power is going to be a lot higher.
3 minutes.
Yeah. So typically you could be doing it in 3 minutes. It's all based on averages over a period of time, which is a 6 minute window that they're talking about.
Can we change that to 3 minutes, go to...
You can do.
Thank you.
Okay.
Nothing.
Yeah, it doesn't make a lot of difference on there. And the main reason is we're still bound by that reactive near field distance.
Got about 10 seconds for competitions, because that's what you're doing, 5926.
Yeah, and then you listen to someone else and then you do it again. So you could be transmitting half the time,
Yeah.
roughly. So, yeah, as I said, there are lots of circumstances where you might transmit more. I think the worst case is if you're transmitting, like FT8, it's probably worst case because you're at full power for half the time, listening for half the time. So, yeah, that's where you're getting into. Unless you're broadcasting, in which case you're breaking the rules anyway.
Kerry, you've got a question from Mark.
Yes, sir.
Kerry, are there any restrictions of these things that apply? Are there any restrictions if you're out on the middle of Dartmoor?
The restrictions apply wherever you are. So, believe it or not, it even applies if you're sitting in your car.
I was going to say, if you're mobile.
If you're mobile and you're parked next to somebody and you're throwing out a lot of power, and somebody's standing next to the car.
Well, even if you're travelling, you know, at the motorway.
Yeah, but the chances of being somebody within I've had some tail chasers before.
Maritime mobile, what about the fish?
Yeah.
If you're staying mobile, so you're doing a cultural activation, something like that, you parked up, but only the beach or the park,
Mhm.
or something. Does that mean your mobile antenna has got to be 3.5 metres higher than the car,
It means it's got to be 3.5 metres away from somebody.
Yeah.
including yourself?
No, because you're exempt.
Yeah, it's not
So
you can
it's
kill
not
yourself,
you.
I think,
Yeah.
not anyone else.
So, so you've got to take up like 4 or 5 parking spaces here.
Yeah, that's it, yeah. That's right.
Yeah.
Steal some traffic cones, man.
Yeah.
Pay for 6 spaces.
Yeah, the actual distance at VHF, if you're transmitting HF mobile, then you'll look at these sort of things. What I just did there was if you're transmitting at 400 watts for 3 minutes out of every 6, that distance goes up to 6.5 metres.
So what would 50 watts on 40 metres be in the car then?
Won't do below, won't do 4.
They won't do it, will it?
Sorry? Can't do 40 metres at the moment.
Because that's what I normally do.
But 40, if we use the same methodology that's been put into the calculator at the moment, it means you're going to have to be 7 metres away from anybody.
What, 50 watts?
At 50
That would be 100 watts, but...
Yeah, it won't make a lot of difference
50
because
watts ain't gonna make a lot of difference.
it's that reactive near field that will dominate as the wavelength gets longer.
7 metres away from the car. That's impossible.
Okay, so sorry about that. But, as I say, at the moment we don't know what's coming in November, because I'm sure that the people that are looking at this are going, hang on a minute, but this isn't coming from Ofcom, it isn't coming from the RSGB, this is going from the international standards group. ICIN, RP and all the rest of that stuff.
That figure in the purple
Yeah.
is not just a height, is it, above ground? It's
It's
a
the
diagonal.
distance from any
Yeah.
part of the radiating antenna to
Yeah.
any part of a person that's not you.
We didn't hear that up here.
Sorry, that purple figure, 6.38 metres on there, is the distance from any radiating part of the antenna to any part of a person other
So
than
it's
yourself.
that way and
Yeah, it could be anywhere.
Yeah.
So in theory then, Kerry, if you've got a dipole rigged as an inverted V, and you've got your centre point up at say 7 or 8 metres, in theory it's compliant at that point,
Hmm,
but if the ends of your dipole are down at 4 metres, you're not.
correct. Absolutely right. And that's where you'd have to get into advanced modelling to work out exactly where the lobes go on that and where the distances are.
Which the average amateur's not going to do.
No, exactly.
But
And even the above average amateur's not going to do either, to be honest.
There is a solution actually,
Hmm.
is when you finish using your radio, you turn it down to 10 watts and you never go above 10 watts, do you?
If your EIRP is less than 10 watts, then you do not have to do any further calculations. You can say, I'm less than 10 watts, EIRP, end of story.
You're all
I presume the calculator doesn't will it still take into account coax losses as well?
Yes, because it looks at power that you're putting into the antenna. So you've got power that's coming out of your radio, you've got losses in your coax, you add those together, and you'll end up with the amount of power that's actually being put into the antenna.
And the calculator's smart enough to do that.
The calculator doesn't, the old calculator used to do that.
Yeah.
New calculator has got nowhere to put those figures in.
Oh, that's what I was
It
asking.
assumes you're going to do it yourself.
So they've chopped that bit out.
They've chopped that bit out. Yeah.
Know the loss for each type of
Mhm.
cable, for each type of cable, you need the actual
You know, the
manufacturer's.
manufacturers know the dB loss per
Yep.
100 feet.
Yeah, for coax, that's relatively easy to get directly from the manufacturers because they'll all quote what the losses are, usually per 100 metres. But I mean, if you've got that much loss to be able to materially affect what's going in there, you've got some shitty coax, to be honest. Yeah. Okay.
Brilliant.
Any more questions?
Right, so if, hang on, what was I thinking? No, anyway, sorry, go on.
Well done.
Is there any in your research on this, is there anything coming out the RSGB or Ofcom, how they propose to police this, or not? Other than us just sitting at our homes,
Yeah.
cooking up some figures on a spreadsheet to make us look good.
Yeah.
You know?
The short answer to that, Don, is no. There is no formal notice of what they intend to do about that, other than the fact that if you do not have written confirmation of your compliance with those, then you're breaching the terms of your licence. The consensus of opinion is they would only do that if somebody complains.
Trouble is, if the public gets hold of this, then
Then it will go, yeah. And I can see that becoming a real problem.
Social media problem is a big
Yeah.
problem.
Yeah.
You know,
Yeah.
period, I mean, for this.
Yeah.
Especially.
But my biggest worry is that the public, generally the public, will get hold of this thing. And every time if you want to put your antenna 20 metres up in the air to be able to comply with this, they're going to go straight to the planning department and say,
So
that's going to be irradiated, and
So
the
what
planning
happens
department
with,
just
with
will not
the,
take the risk. They'll
what
just
happens
stop it.
with the planning department if you want to put a mast up or whatever it is, you know, on your, have they got to come and have a look at it
They won't give you permission, will they?
and do it that way?
No. No,
And
they
these people that are doing these aerials,
Yeah.
have they got machinery
no.
to bring with you or to bring with
No.
them?
The
test
the
your
planning
area?
departments do not care. The planning departments will assume that if you're a licensed amateur, you will have done this work.
The only
But the
thing,
biggest worry is that the public will use it as a weapon
Yeah.
to try and stop you from getting that planning permission.
Well, my uncle's getting headaches, you know.
All the neighbours were-
Since
You got
Jack's moved in.
Yeah.
When this was first introduced, the RSGB and Ofcom did publish a joint letter or statement in Radcom, and essentially speaking, Ofcom stated that they weren't looking for convictions out of this. More, they were hoping to work with the RSGB and the operators to assist in compliance. But if you take into account the fact that there were two guys to cover Bristol to the Scilly Isles to the Hampshire border, that's a lot of driving around. And then when you point out the window and say, have you not done that knocket over there, who's got a silver rod running 15 watt sideband into an 11 metre band radio, CB, have you knocked on his door? You know, it all becomes a bit of a...
I know it's the public's conception of it, because we had a, when I worked at Bude, we had a 90-foot dish, no, 102-foot dish with a 90 dB forward gate pointing at the Indian Ocean.
Yeah.
The angle of elevation was 1 degree, so it was pointing
Yeah.
right at the little village on the A39 running there. And we got complaints about people with headaches and that. We weren't even transmitting.
It's receiving only.
There was no transmission, we were just listening. But people complained, oh, you know, you can't put that on, you know, but, you know, there is no radiation at all.
Yeah, there's
Zero.
something in Aldershot.
But people would be ringing up Cheltenham and saying, you know, this dish you put up, is, you know, my baby's having sleepless nights, and you know, we are. It was amazing.
Yes, Mark.
Joined to what you've just said, my father-in-law is now Silent Key, but he stuck up an antenna on his bungalow, which was as big as the bungalow. And he had a phone call from a neighbour up the road saying, excuse me, your antenna is interfering with my telly. He said, well, that's funny. He said, because there's no cable connected at the moment.
Yeah, that's right.
It all happened.
It's
Just see it
it's
happen.
how the sort of the uneducated, if you like,
You've got a question for Mark?
perceive it.
Is any idea why this came about? Has somebody done a survey and found that the death rate next to a radio amateur is higher than normal?
This has actually been going for a long time. So any professional radio installer, professional radio planner has had to do this.
Yeah.
60 years ago on a destroyer, you could go up on the top deck, which is just sort of up above any where sailors and marines used to be, and up on there was a 640 antenna for the 640 transmitter, pushing out 800 watts ish, and around that antenna up on the top, and we're only talking about 8-9 foot up on the top. There was a round piece that was taped off. Do not go in there when we're transmitting.
2 minutes
Look,
in
Jack
the
doesn't know when the bloody ship's transmitting, and nobody ever went up there, but that was beside the point. That's how big a circle it was.
Yeah.
Do not walk in that area.
You were allowed to remain in 2 minutes in any 20. But I mean, you did. You know,
Yeah.
anybody was wandering around there, you didn't know when they were bashing away on the key down the wires of it.
I mean,
It's global as well, I mean, it didn't over here.
No, this is
Everywhere.
Yeah, but you don't see much on the social media from other countries, do you?
That now brings us to a point here.
Yeah, I don't know what other countries are doing at the
All
moment.
Day Society, I told you before, we did an NFD in the compound at Stockport, just putting out how many thousands of kilowatts, how many, well, you know, how many,
Yeah.
you know, 300 or 400. All, we were there operating,
Yeah.
and our hair was stood on end all the time.
Okay.
I know that went there, was still here.
Yeah, here's a nice one for you. If I walk across Dartmoor and I walk under an electricity pylon, okay, reactive near field electricity cable.
Yeah.
Okay, they're chucking out what, a couple of megawatts down one of those wires.
That's just one.
What's actually being radiated is quite a lot less than that, but it's still, you're talking about watts. Rather than
You
anything else.
drive up the A30
Yeah.
to Honiton.
Yeah.
As you go on the Honiton bypass, there's a big cable. You switch your car radio to
Yeah.
medium wave.
Yeah.
You just get this just blanks medium wave out. And it's only about
That's if
50
you've
foot.
been there.
And they're exempt, believe it or not.
Yeah.
Frightening, isn't it?
Great, isn't it?
Thanks, Kevin.
I don't know if this is true, and talking about radiation, is that there was, I think it might be an American guy, the bloke who invented the microwave cooker actually discovered that microwaves heat things up because he was working on something and he had a Mars bar or something like that in his pocket, and it melted in his pocket. Whether that's true or not, I don't know, but that's I suppose that's what can happen if the frequencies are right. But again, this my I don't know, perception of what I've heard is that the higher the frequency, the more harmful it is. You know what I mean? So therefore, as the frequencies go down into very long frequencies, I mean, you think like top band is very close to the commercial bands, isn't it? It's only a few hundred kilocycles off. So, you know, I mean, it's almost you can't cook a rice pudding with the top band, so it's better.
when you think, I want to go on top band, and you've got to have a 25 metre distance or whatever, yet look at where the medium wave broadcast areas are. They're in the middle of a field, only a dipole, with nobody around them.
Well, I don't know, there's one at the top of my road.
Yeah,
I don't know if it's
I
active.
don't know if it's happening, I don't know.
Radio Dem was on there, wasn't it?
Sorry?
Was it Radio Dem or?
Something like that. It was fairly recently.
Yeah.
Two great big towers and everything like that. And there's houses across the road.
The BBC have shut down all their medium wave. It's only commercial.
Yes, Mike.
The big PPI radar scanner at Heathrow,
Yeah.
we used to have to go round as a telemender and bung a filter in the mains because their television would go. That's all very well with the television, but I wonder what it's happening to the people themselves.
Yeah.
And are they exempt, I suppose?
No, that's why I've got great.
There's a lovely story, I'm not sure how true it is, that when the submarine broadcast radiated from Rugby, and we're talking 60 kilohertz, 19 megawatts. Okay? So you can imagine the hardware that went with that, but then it was global coverage, you know, on VLF. So you got, somebody put a coil of wire in their house, in the attic, and generated
Taking
power.
power.
How true that story is, but that was one story that was quite legion at a while. But that's still, I mean, it's not at Rugby now, it's up at up north, I mean, Inskip, I think, or Criggion. But that's still poking out, you know, a few megawatts.
Yeah, you got the radio time signal.
Yeah.
They're 70 kilohertz.
Yeah. Yeah,
Chucking
that's
out
global
a
coverage.
fair amount of, yes, fair amount of power coming out of there.
It's in the middle of a field.
But it is in the middle of nowhere.
Yeah.
But judging by this sort of thing, it shouldn't bloody need to be in the middle of a film, doesn't it?
Okay.
Do you think the answer could be just claim your QRP?
Yeah.
Well, the question that was asked earlier is how are they going to police this is a very, very good question. Because if you think about, if they wanted to prosecute you, they've got to prove that you were, at the time of that transgression, transmitting more power than perhaps you say you were,
Yeah.
and that that person was within that distance from where you. It's
So
going to
you
be
could use
almost.
your own logs to
It's yeah.
that your own logs would possibly give yourself away then. Because if you could
You're not obliged to keep it.
But you're not allowed to keep it.
Yeah, most people do, don't they? You know,
Yeah, exactly.
I don't know on the
transmit out.
calculator on the RSG
Make
piece,
sure it's right.
you know, the way they do it.
Yeah.
Has it been updated?
I think we're on version 1.0F.
So you need to get the latest version, obviously.
Yeah, you need to. They keep getting updated. I think this one's actually been there for a little while now, from the 0.1 that was there before. But
Kerry,
yeah,
where do we find all this stuff to fill out.
If you go on
I've looked
to,
on the RSGB thing, and it's just file after file after file after file. I don't know
Okay.
which one to look
if
at.
you just put in to Google
Yep.
or any search engine RSGB EMF calculator, it'll take you straight there.
Really?
I'll write that down now.
Forgot what we were asking now, sorry.
You know, we had to do the other ones previous for the 110
That's what it is,
up. Do we have to put that into the new
If you
calculator?
haven't done your assessments already,
Right, I have done them on the old,
So-
but I didn't need to.
yeah. So
But-
this is for anything from 10 meg, you see on the top left-hand side, 10 meg to 300 gigahertz. So basically, anything above 10 meg, you now have to demonstrate your compliance.
So when I've done it with the older system, I can leave them and just...
Yeah, you can leave it, but you don't, sorry,
And
if
just
you've
do-
already done them,
Yeah,
you don't have to redo them on this
Right.
calculator, because the results come out the same. This one has been extended to be able to cope with frequencies down to 10 meg. And one would assume in November, if they get a calculator that goes down, the results that you get if you put in something above 10 meg will be the same as you get.
so 30
Otherwise it's going to be
metres,
hard.
30 metres to 4
It's
metres.
come to me, sorry. The version that I downloaded, I think, was the second version that they released.
Right.
That definitely had details about what cable you was using.
Yeah.
and everything.
Yeah.
Have they taken all that out? you say?
You can still get access to the old ones, but they're not. Yeah, I think you can still get access to the I think that was 0.1 or 0.2.
I can't remember. But,
And this is now
all I know is it
1.0.
definitely had, because I was surprised that the coax that I use on my main aerials, the ones that I use most of the time, are it's called H100. And it's not available now as far as I'm aware.
Yeah.
I mean, and I was surprised it was actually on the list.
Yeah.
You know what I mean? But if you can't put it in there, how do you? I mean, I must admit, I wouldn't know how to work out the losses, especially H100. Where do I find that?
If you put in Google H100 cable loss,
Really, and it would,
and
the chances are
it
it'll
will
come
come
up.
straight up.
I'll try that. Thank you very much.
The other way is to put a power meter on the end of the coax.
Right.
Putting that end of the coax.
Okay.
Yeah.
Will you come round and climb the ladder?
Well, I have got a saw and I can cut the pole down.
It better be a metal saw.
Okay.
Right.
Thank you.
Are you done? Brilliant. Well, I think we have to say a very big thank you to Kerry for that. That's it's much appreciated. It's going to keep us all out of trouble, fortunately. So, just on the subject of EMF, and for your amusement, takes me back before Don and